Alright, so we have talked about direct variation. Let's go ahead and talk about direct variation. Inverse variation. Inverse variation, as one thing goes up, the other thing goes down. A couple examples, see if you can think of any. The one that jumps to mind for me, maybe free time. And how about homework time? The more time you spend on homework, the less time you have free. The more free time you spend, the less time you have to do your homework. So they are inversely related. And we can also have powers, just like we saw with direct variation. We can say y equals k over x, or if we have a x over n, if it's inversely proportional to x squared, just like we saw in the last example. Let's take a quick look at this problem. Example 5 is going to throw together direct and inverse variation. See if we can do it all. A gas law states that the volume of an enclosed gas varies directly. Going to stop right there. Say V equals K, because we're directly as the temperature. So I'm going to say T. And inversely, so underneath the fraction bar is going to be our inverse stuff, as the pressure. So if we have variation, we're putting that variable k in there. Direct would be in the numerator and inverse would be in the denominator. Let's go ahead and solve from there. The pressure of a gas is 0.75. The temperature is 294. And if we have those situations, the volume is 8,000 cubic centimeters. And so let's go ahead and get k by itself so we can have an equation, and then we'll plug in some different values. So first thing we need to do is times by 0.75, which is 3/4. 3/4 of 8,000 is 6,000, equals k times 294. Let's go ahead and divide. 6,000 divided by 294, if the book can be trusted, is going to be 1,000 over 49. The book leaves it as a fraction, so we'll go ahead and do that as well. 1,000 over 49. If you did a decimal, definitely would not be wrong. So our equation is V equals 1,000. T's in the numerator, over 49, P's in the denominator. That would be the answer to the first part. And then the second part, B, find the pressure. That's A. Part B, find the pressure when the temperature is 300. I'm going to go, just for the space, put it over here. Let's find the pressure. So we will not know pressure. P will be a variable. The temperature is 300, so 1,000 times 300, and the volume is 7,000. All right, from here it's the straight algebra to get it by itself. Let me create a little space here. All right, so let's bring this to the top. 7,000 times 49p. Equals 3 with 1, 2, 3, 4, 5 zeros. And so we'll need to divide by 7,000 times 49. Multiply it all together, and P equals 0.87. Go ahead and see if you can do it on your own. All right, in exercise 77 and 78, we'll do 77. Use the fact that the resistance of a wire carrying an electrical current is directly proportional to the length and inversely proportional to its cross-sectional area. If number 28 copper wire, which has a diameter of 0.0126, and so diameter, cross-sectional area. They're throwing a little trick here. So area is going to be the area. If we look down at the pipe, they're telling us here the diameter is 0.0126. Which means to find the radius, we could divide it in half. So if we took that and cut it in half, we'd have half of 126 is 63. And so for the area, we're going to need to go, area of a circle is pi r squared. Let's go to our calculators. 0.0. Come back, calculator. 0. Oh, looks like we're not going to cooperate. Give me a second, I'll pause you and make this cooperate. Alright, so it turns out the area here is 0.000124, and so our resistance, they tell us, is 66.17. Don't know K, and the length is 1,000 feet, right there. And we'll go ahead and solve for K. So we'll multiply both sides by 124. And so 1,000 K equals 0.0083. And so we'll divide by 1,000. That's going to move our decimal 3 places, so 0.000083 equals K on this one. Another way to say this is R equals, in the numerator, 83L over 1, 2, 3, 4, 5, 6, 7 zeros. 3, 4, 5, 6, 7. 83 over 10 million. Alright, so if we get this as our solution, we can plug in a resistance of 33.5 instead of the 66.17 here. I'm going to just pause this here for a second and get some numbers on the calculator because it doesn't seem to be cooperating very well. I'll be back in 1 second. Alright, so plugging in for R, 33.5 equals 83L over 10 million. We should get an answer of 403,000 approximately for L.